In this demonstration, I will show some examples of rotation surfaces in ENSnano. This first example is a Möbius torus. That means that it is a torus twisted so that the section makes a rotation on itself. And this can be seen here more easily because the section is not a circle, but an ellipse. Here are the parameters describing this shape. We say that it is a curve, an ellipse, with a minor axis of 1 and a major axis of 2. This will be rescaled to adapt to make the real shape. The number of symmetry per turn is the number of rotation that the section make in one turn. So here it is indeed 1. The radius is the radius of the structure. And here are other parameters, such as the number of helices per section, and etc. If I modify these parameters, for example, if I change the aspect ratio of the ellipse to set the major axis equal to the minor axis, I get a twisted torus where the cross section is a circle, so there is less asymmetry, but still there is still a twist in the structure, as can be seen here. I can also increase the number of symmetry per turn to create a much more twisted structure. And this creates a quite complicated shape, but even with this shape, making crossover in the 2D view works thanks to the automatic synchronization. So, for example, if I try to make this crossover, it will connect nucleotides that are quite close together, and I can then adjust the crossover easily in the 2D view. So this 2D representation allows to easily interact with the 2D view. Finally, I want to show a last example, which is a big Möbius torus that is big enough to make a full DNA origami with a scaffold of length 7,560. Notice that even though there are only 2 helices in this design, that each make 10 turns of the structure, there are 10 fragments of helices in the 2D view. The helices are splitted so that the edition of the design is easily done in the 2D view, and all crossovers appear almost vertical, which made the edition of the structure much easier. That's all for this demonstration. Thank you for your attention.